All right, so let's get started. So thank you, everyone. Thank you for joining Damotech's rack safety webinar series. Today, we're going to talk about assessing pallet rack issues. So basically, we're going to go through those details. So for those of you who are joining us, either if you're in the East Coast, if you're Central time zone, or out in the Pacific, good morning. And for those of you who are from the Atlantic time zone, of course, good afternoon. So let me introduce myself. My name's Eric Manaigre. I'm the Vice President of Sales here at Damotech. And I have here my co-host and actually our guest speaker, Charles Carbonneau. He's our Ph.D. He's our Chief Engineer here at Damotech. And with that, Charles, good morning to you. Perfect. So let's go through the course content for today. We're going to start off by talking just the basics elements, why the importance of rack safety. We're going to go through how to identify rack damage. A part that's, we get asked this question a lot is how to understand that severity damage. So we're going to walk through some examples, some live pictures that we've taken over the course of the years that we can showcase, and help you identify that severity level. And last but not least, we're going to go through just quickly some tips and tricks on how to implement an inspection protocol. And of course, we're going to wrap things up with a Q&A. For those of you, if this is a new experience throughout through this webinar event, what we normally do is the lines are currently muted. With that, if there are questions that you may have either throughout the presentation or towards the end, we do want to interact with you. So don't hesitate, either on the top of your screen or the bottom of your screen, depending on what device you're using. There is a box called Q&A. You can click on that box, ask your questions, and again, we're going to do our very best to answer them throughout the presentation. Or like I said, we'll do our best if we have the answer them at the end of the session. All right, so let's get started. Why rack safety? Here at Damotech, when we look at racking, we actually get really excited about racking, and the reality is that they're really impressive structures. And the reason why I say that is that pallet racking systems are designed to be highly efficient structures. So again, they don't use up a lot of material. But what's great about them is they are engineering structures, and they're designed to maximize the most vertical loading space, to maximize a warehouse, but again, using the least amount of material. And with that, they're there to maximize not only just the vertical space, but also maximize load capacity. The reality and the way that we view racking here at Damotech is we see racking as a living entity. It's always going through a constant flux of change. And what I mean by that is that, through the course of time or through years, a racking system that it was originally installed, will evolve over time. You're going to see the evolvement from just, the typical, the dents and scratches, and of course the damages. You'll have the constant movement and shifting of what's going in and out of that rack. You also have modifications that are done throughout the years, right? So you're going to change the beam elevation. There's sometimes beams get removed. Sometimes a racking system will add more to the system. Sometimes we'll remove. We also encounter, this happens very frequently, that a racking system will get moved into a different place of the warehouse. So again, that racking from that original design will change over time. Here's the harsh reality about racking. As I mentioned, a racking system is designed to be, it's an efficient structural design. They're not designed for impact. So we always play we always make the mention, forklift versus rack, who's going to win? 100% of the time, the forklift will win. So, with that, it's important that we think about the risks associated to racking from those impacts. And here's the other harsh reality, is that a warehouse is a dynamic environment. It's not just the fact that you find yourself with a lot of, at times, traffic. You have just this constant movement of inventory being loaded, unloaded off that rack. So you're going through that wear and tear. Not only that, that warehouse environment has heavy traffic from heavy equipment. We talked about the forklifts. Again, they play a heavy impact. And again, it just puts that extra stress onto the racking system. Here's the most important part to retain is that damages on a rack can occur at any given time. I think we know that. But if it is left unaddressed, this racking system or the racking system can weaken and over time can lead into unsafe warehouse environments. So what are the issues that we typically run into? I think it's pretty, call it pretty generic to see these images. And again, we see these types of scenarios all the time, but I always like to add the component that, there is the physical damage that you find in a warehouse, but there's also, call it the behavioral component, right? So these incidents are going to occur, but sometimes call it either a warehouse manager or a warehouse owner does not realize that this damage can actually have a serious impact. Sometimes it's simply from a lack of knowledge. Other times it's, I don't like using the word ignorance, but call it complacency. So given the fact that there's been damage over time, potentially multiple damage, and for whatever reason, there has been no collapse, the rack has not fallen, no one has been injured, so therefore it must be okay. You have other behavioral components where, an act of good faith, warehouse owners will attempt to try to fix it. And they think they're doing the right thing by, for example, doing a homemade repair. In this case, you see an image of someone who attempted to weld a rack that was damaged. You'll find out through the course of this session that in this situation, this actually has made the rack worse and therefore creating a higher risk level. And then there's other times where we just run into these, call it unbelievable situations. And, and again, they can, cause us to at times crack a smile, but the reality is that, these situations are, driven by either there's just no sense, there's an opportunity to drive a better safety culture or safety agenda within the organization. Other times it's, there's just certain companies just don't have the dollars. They don't have the repair and maintenance budgets available to take the right action. And therefore, these issues occur. Here's the reality. The reality is that if these issues are left unaddressed, they can turn into tragic consequences, becoming a rack collapse. And here's the, here's the fact. A lot of people think that rack collapse don't happen very often, and if you go onto social media, if you look online, you have your typical 5, 6, common videos have serviced and have played over and over. But the reality is that we encounter these issues quite frequently. And again, they can happen, and that's why it's important to keep rack safety top of mind. So across North America, there's different types of organizations who are there to, drive that safety agenda. And again, we kind of look at this as, the guiding principle. So you have, OSHA, right? It's basically, you're looking at, it's a government body that, requires for employers to maintain a safe working environment. And again, OSHA is the most commonly known one that's out there through the U.S. On the Canadian side, you're going to encounter either the Ministry of Labor. In the Quebec market, you have an organization called CSST. You'll have city inspectors, right, who are there to ensure that they're inspecting warehouses to make sure that it is a safe working environment for the employees. And it's important to note that, these organizations, they're not there to look at the entire infrastructure of the rack. They're not subject matter experts per se in racking. They're there to inspect and see if there's any improper use, if there's been any improper installation or maintenance of the racking storage. And again, what they're looking for is to see if there's any risk of a worker of getting injured. And that's important to highlight at that point. On our end, everything that we do, our focus and call it our guiding principle really relies behind what we call the rack design code. In the United States, we have a design specification that's been around for more than 30 years. And it was started off as a recommendation by the Rack Manufacturing Institute, known as RMI. For those of you who are unfamiliar with RMI, call it, it's a governing body. It includes racking manufacturers, rack repair companies, subject matter experts, engineers, and over the course of time, this is the organization that provides recommendations. They created from the get-go this article code called MH16.1. But then in 2012, it became an American approved standard through the American National Standards Institute, known as ANSI. And that code today is known as ANSI MH16.1. And now, and since then, it's been referenced by the International Building Code IBC 2012. So again, this is a lot of information, but very, very simply put, if you have a building and you have racking that's in it, then you must respect this racking design code. So just to give you some idea of what is in this code, you'll find content that will cover off design specifications, loading combinations, notions of various forces, including seismic activity. You'll find overall designs and design procedures, steel elements, stability, effectiveness, information on base plates. You'll find even some information on slab concrete evaluations, anchors, bolts, test methods, etc. So basically, when we have our engineers and they're out there in the marketplace and they're doing these rack inspections, basically this is the Bible. This is what we refer to. This is what we dive into in order to make those evaluations. So for those of you who are in the Canadian market, very similar situation. So we have what is called the Canadian Standard Association, known as CSA, and they have today what they call the 9th edition of CSA S16-19, which is the design of steel structures. So as you can imagine, this really contains similar information to ANSI. So general information on definitions, specifications for steel and welding, connections, design requirements, stability and loads, seismic and horizontal forces, base plates, tolerances, interactions with the building, documentations, and actually a very interesting component on the use of pallet racking. So all in all, these documents actually can be purchased. You can either go through ANSI, you can go through CSA, but they do cost a few dollars to get this material. And this is why we're here today. This is why we wanted to put together this webinar, is just take some of this information, the summary of these details on the rack design code to help you better understand the racking that you have in your warehouse, but most importantly, what to look for to determine if there's some potential risk. So with that, I'll going to pass it over to Charles, who's going to walk us through how to identify a rack damage.
Thank you, Eric. I'll just take control here. You are controlling. There we go. All right, so let's delve into it. So what do we want to look for in terms of issues? Rack systems are rather simple structures. They are composed of, there we go. So we've got uprights and they are attached by beams. And there's a third element that we think is really important and that not a whole lot of people talk about. These are LARCs. So LARC stands for Load Application and Rack Configuration Drawings. So the example you have here is just a load capacity plaque. But usually when you buy a rack from a manufacturer, it comes with a set of engineered drawings where they have calculation and they specify the thickness of the steel, the arrangement of the uprights, and generally all of the beam configuration and beam size and beam elevations as well on the rack systems. And that is really important to match what you have out there on the warehouse. If you lost track of these documents, I encourage you to get them back either by contacting the original equipment manufacturer or a company such as Damotech, who goes in, measures everything, recalculates the capacity, and hands you a full report. Now, when we look at issues on the uprights, when you get in the details, that's where it comes out as being a little bit more complex. So we'll process through these elements here. So what's in an upright? You've got the base plates and shims, the anchors, the columns themselves, the blue parts that we see on the screen, the orange braces there, and we have to watch for the upright verticality, that just to make sure it's not out of plumb. So what about the columns? So issues on the columns can stem from impacts with the forklifts, of course, which is the most common. You can have deformation of the columns, from impact. You can have small dents, you can have some twist. And by the way, there was a gentleman that asked a question on our website and just now through the Q&A portion in Zoom. And he was asking, you know, what do you recommend in terms of maximum twist? And you can find on the web certain references where people put a square, you know, around the column. And if it's twisted by half an inch on the footplate, you know, that's the limit. Well, it depends. As a general rule, not bad. You know, if it's a 3x3 cold form column, not too bad. If it's a structural steel column and it's a single column, then we get into a different situation. Maybe we are not that tolerant. Maybe a 1/4 inch would be the maximum twist that we would allow. So twist is something that has not been super well studied on the behavior of columns, and the buckling of these columns in a compression and torsion capacity is somewhat limiting the capacity very much. So sorry, I'm getting into the engineering details here. Other stuff that we need to look at is signs of weakness. If you are standing in front of the rack and it's doing sort of an S shape between all the beam elevations, it is overloaded. You have to unload it immediately. That's a sign that if you load it some more or vibrations or little impact, it's going to come down. It is overloaded. Sheared base plates, like we see on these images on the right, the top one, it's been impacted. You can shear the anchors as well. We see that quite often. And the beam connections, you know, for cold form racks, you have these teeth that come in and attach on the columns. Sometimes they are torqued for a specific incident. If they are deformed, you don't have the same lateral stability. Which brings me to another question that somebody was asking: can you mix different types of teardrop racks from different manufacturers, right? So usually they make their beam connectors compatible with different columns so that you can mix, but there is some risk in terms of lateral stability. So only the beams are giving you this lateral stability when you look down the aisle. And if the connectors are not tight and specific to that type of column, you can get in trouble in terms of lateral stability. So here's a little example about what damage does to a column. And you've seen this in the warehouse. You know, there's dents left and right. So can a normal column hold my little book here? Yes, of course. This is a normal 8.5 by 11 inch sheet of paper, bigger book, fine, no problem. What happens if I damage that little column? And you can see that's my little lift that I have just in the back of me. And so I just folded the paper. It's hard to see, but there's a fold at the bottom. Can it hold the load still? Yeah, and that's what you observe out there, right? But, and yeah, this is kind of an exaggeration, but that's the problem. You know, when it goes, it's rather violent, and all these little damages, they sort of accumulate along the height of the upright and can lead to disaster. Now, in terms of impact on the columns, what is the tolerance? You know, what do we tolerate? So this is not by code. By the way, the engineering codes never say how much damage is too much. They say basically, oh, well, if it's damage, unload it. But you realize, you know, as soon as you see a little dent, unload the whole thing. Yeah, there's a reality you have to address. And so what we say, we come up with this guide, you know, and it's based on a proportional of deformation. And we're saying, you know, use this 1, 2, 3 rule. So 1 meaning 1/8 of an inch of tolerance on a frontal impact. If you're below that value, don't worry, it's a scratch, it's a dent, right? If you're above that value, you're entering a gray zone where, okay, well, I know it is impacting the load capacity. If you are double that value on a frontal impact, well, you got to replace it or repair it, right? So a 1/4 inch of frontal impact, that's it, that's your limit. If it's at that or above, replace it, repair immediately. For a side impact, since the columns usually, you know, you've got a 3 inch by maybe 1.5 inches deep or a 3x3, we tolerate a little bit more on the side because they are stronger in that axis. And so we say, okay, let's go to 2/8. So that's the 2 rule. And that's a 1/4 inch. If you're above a 1/4 inch, you're entering that gray zone. If you're beyond 1/2 inch of deformation, that's it. That's replace the column. For a brace, we tolerate a little bit more. That would be in non-seismic zones. Of course, if you're in a high seismic zone, then you might say, well, the bottom braces, I definitely need them to work in tension and compression. I'm not going to tolerate beyond anything that's 3/8 of an inch. But typically you would say, you know, at 3/8 of an inch of deformation, I'm entering that gray zone. When I'm at 6/8 of an inch or 3/4 inch of deformation, that's it. I replace it. Seismic or non-seismic, that's it. That's my limit. So that gives you a little idea. It's not in the code. Like I said, the codes won't tell you how much is too much. They basically say, well, invite an engineer, have an engineer come and look at it. What else do we have on uprights? The bracing that attaches these 2 columns together. If they're detached from the column, and that's what we're showing here at the top, of course, that's a big problem. You have to fix it immediately. What we're saying also is if it's deformed, badly deformed, they have dents and twists. You want to watch for cracks on the welds. You know, in North America, the majority of racks are welded racks. So the bracings are welded to the columns, and you might see a little black line in the paint that it may indicate a broken weld. You got to watch for those. Detached or missing component, that's what we're expressing here on the left. And missing brace is one of the hardest things to inspect. When I walk a facility, sometimes, you know, nothing looks more like an upright than the next upright. They're all the same, and your brain starts to fall asleep looking at it. It's really hard to stay focused. And so when we train people on how to inspect, sometimes we tell them, just focus Monday on the anchors. Just look at anchors. Don't look at anything else. Of course, if it's really clear there's a big damage on the column, yeah, act and take a note of it and act. But you know, you focus on just one thing so that you don't have too many elements to look at the same time. Now, loose bolts or missing nuts is something we see very often, because the pallets will rub against the nut of an anchor, and sometimes they come out. Rust. So these 2 pictures are rather extreme. You got to watch for rust. Basically, what we say, if 10% of the thickness has been attacked, that's when you get into that gray zone, right? And if you're at 20%, well, you know, it's time to act and repair or replace the upright. Sometimes the rust is hidden, like in the picture on the right. This used to be like a rubber protector that was at the bottom there, and with time, humidity, food, and whatnot got in there, and it totally ate away at the front column. So if you have these racks where you have your charging stations for the battery, you know, the acid that you have there will attack steel, so those you watch over. Of course, they don't have the same load as typical racks, but again, watch for that. Welded repairs, these are the things that we see out there, and Eric showed some of the very imaginative ways to solve these things. So the code is a steel design code for racks. They can't be in concrete, wood, plastic, or whatnot. We only have a steel design code. And when you do these welds, they do affect the properties of the mechanical properties of the steel. And so for an engineer, it's really, really hard to decide, is this good or not? And especially when you look at these pictures where you see they did not even prepare the surface. So they welded right on top of paint, and that will contaminate the weld, right? So the adherence between the metals that you're trying to accomplish, it's a mix of chemicals, and there's paint in there that's been mixed. And so to me, the picture on the right looks really good, but you ask an engineer to take responsibility on this and say, yes, you're fine, you can operate, and I'm putting my name on it and go ahead. Well, it's worrisome for the engineers. They really don't know what to do with this, other than taking an X-ray or taking the beam out and testing it, crushing it basically, and then telling you, oh, it was okay, you were fine, but now it's destroyed. So these welds, you can repair with welds, but they got to be engineered, executed by a certified welder, and or they can be done by the original equipment manufacturer. So he would probably do that in their shop and then send you the materials, and it wouldn't look like this. Shims and anchors, of course, pallet racks must be anchored. That was one of the questions that I saw go by before the presentation. And everything that's operated with a forklift has to be anchored. That's in the code. The anchors have to be properly tightened, right? So many people ask me, well, how many anchors? There's 2 holes in the back plate. Why only 1 anchor? That is specified in the LARCs. You know that third portion I told you, columns, beams, and then LARCs? The LARCs, the engineer said, okay, for this system to work, I only need 1 anchor. We're good. Or for this system to work, I need 4 anchors. That's what we'll see oftentimes in seismic zones, right? They want that base to participate in resisting the seismic forces or the uplift in the cross-aisle direction. The shims that we put under these columns, they have to be of the same size as the footplate itself. That is in the design code, right? And you got to have a way to prevent them from twisting. So usually when the LARC say that only 1 anchor is necessary, if you put a second one in, you have not made things worse, right? If anything, you're preventing these shims from rotating. That's a good thing. More modern footplates, some manufacturers have a little notch in the footplate, and all the shims also have that little notch, which prevents them from twisting sideways. The verticality, that is the out-of-plumb. So the code says you're allowed, when loaded, 1/2 inch of lateral deformation, either down aisle or cross aisle, over a span of 10 feet tall. That means for a 20-footer, that means a full inch. When you stand in front of a rack and you look at it, you will sort of feel that it's leaning, right? If you have an incline ceiling, you lose all reference points. You cannot know. You need to use a torpedo level with a little bubble. It'll show you if it's straight or not. And that's it. All right, let's move on to beams. So what do we need to look at for beams? You know, the deformation of the beam, deflection of the beam, the connectors at the extremity, the safety pins, presence of safety pins, safety bars, the wire mesh, if any, that are used, and the pallets. And there's one more point that we'll address, and that is when you move beams around, right? So we'll have a special slide just on that. Deflection of the beam. So that would be natural deflection under load. And the code says you're allowed the length of the beam divided by 180. And so for a 96-inch long beam, an 8-footer, that is 1/2 inch. And again, when you stand in front of a beam that is deflecting, an 8-footer deflecting by 1/2 inch, you would think this is wrong. But then you measure it and you might be right on, right? So deflection is not a real problem if you stay within these limits. You have to know that beams are designed to withstand double the design amount. The way we design those, we test them often because calculation works, but testing is the ultimate, right? You really test them. You put, if like for this example, we're saying these are 2,500 pounds pallet, we would put 5,000 pound pallets, 2 of them, 10,000 pounds, and then we expect something to break, either at the connectors or somewhere. But the beam might not break at all. It might be the welds at the extremities, or we damage the holes inside the column, right? That's enough. But usually the beam will not break. The connectors at the end of the beams, you have to look for signs of corrosion, always, deformation of this. And if you see that the paint has these wavy lines in there, it's been torqued a little bit too much, right? And so again, back to the deformation of that beam, if that beam was overstressed, it might have twisted the connector with the teeth in there. And if you see these lines on the paint, you might want to replace the beam. And again, I always say, you know, for the price of a beam, don't take any chances, just replace it. Cracks in the welds. If we have cracks in the welds, again, a little black line that appears in the weld, you might want to replace this. And of course, the connector, the teeth that come into the holes of the column, if one of them is deformed, just change the beam. It's very hard to repair beams. We don't recommend it. When to replace them? Well, in this picture, in this particular case, we see it's been severely dented, and they put these black X's to show that it should be replaced. So what we're saying, and what I've seen, again, not the codes. The code don't guide us on how much damage is too much damage, but the European code gives us some indication. And what they're saying is, when you're deformed by 1/4 inch on the front face of the beam, that's your gray zone where you enter it. And I would say, if you're deformed by 1/2 inch and it goes from the middle of the beam all the way to the flanges, or just about 1 inch from the top and bottom flanges, imagine yourself being either the manufacturer of these beams or an OSHA inspector. How would they see this, right? And the thing is, sometimes we explain, you get an inspector in, or an engineer, they go in and they see one, and then they see another one, and then they imagine the whole thing is a mess, right? And so they start digging and looking very deeper into it. So when you see these little things that are easily fixed, just fix it. It's easy to say, I know. Frontal connectors, if they're damaged, like I said, replace them. And if there's a permanent deflection, that would mean it's been loaded. When you remove the pallets, it's still doing like 1/4 inch sagging. That's a sign that it's been overstressed. Just replace the beam. Safety pins, look for damage or missing safety pins. And when we inspect, usually that's what we see, a missing safety pin. They are mandatory. So these safety pins, they prevent the beams from unintentional uplift. So you're raising the load from, you have to imagine the forklift operator is raising a load like this. From the bottom, you don't really see that you're trying to, the product on your pallet is trying to raise the beam that's above, right? And so you don't want to raise it, then pull away, and the whole thing comes down on you, right? So these safety pins, that's why they're so important. They're designed to withstand at least 1,000 pounds each of uplift like this. But since you're raising one pallet on one side, right, it's basically that just that side which will have that uplift. Sometimes we see when we inspect vibrations, we'll sort of have them not totally come off, but they're like unhooked. And oftentimes we'll recommend just put a bolt in there and a nut and forget about it. It's going to be forever. Now, the choice of the diameter of the bolt has to be the right thing. So please have someone look into it. Safety bars, they are not mandatory by the code, right? So you could operate without these things, but if you do have them, they must be attached to the front and to the back beam. We don't see that often. It's rare that people do just because they don't know, right? But that's what we're saying. You have to have at least 2 bar per pallet position. They have to be attached. Imagine that at the 5th level, 24-foot tall upright, and you're operating a pallet, and I don't know how, but it does happen. One of them falls, right? This little thing coming down from 24 feet can hurt someone pretty bad. Other than that, make sure that the pallets are wrapped so that boxes don't fall off of them, and that you have correct pallet positioning, that the pallets don't try and fall through. They're not twisted on the beams, and provide safety nets. If there's pedestrian on the other side, provide something that protects from the products or the entire pallets from falling through and down on the pedestrians on the other side. So pallets, I won't touch too much. If it's dirty, it's there's nails sticking out. Of course, you want to change them or fix the problem, but more so, ask the pallet manufacturer if it's okay to use these types of pallets in a drive-in, like the situation on the picture on the right. It's not made to go in a drive-in. It's too flimsy a pallet to be able to do that. You can see how much deformation you have in there. It's broken on one side, so that's a typical sign that you have to change that pallet. So let's move on to the third part, the LARCs, load application and rack configuration. The code says that you have to maintain up-to-date documentation. And why is this important? Well, somebody somewhere did the calcs and said, well, you can put pallets of 2,500 pounds if they are at these beam elevations. And you have to understand that changing these beam elevation does affect the load capacity. We'll show you a little video soon after that. And so if this is not respected and there's a collapse, you go back and you say, well, we had this documentation, and then they look at the documentation and they look at what you have and it doesn't match. So it's on the rack owner to make sure that these things match and they're safe to use. So what we're saying, you have to understand, have an understanding of the beam design, the elevations, the load capacities, and this is required. So the IBC, Eric mentioned it at the onset, the International Building Code says, well, if you have racks inside your building, you have to follow the MH16, which is the rack design code initially written by the RMI, the Rack Manufacturer Institute. So you have to, and the code says also, you have to provide a visible sign or something so that the forklift operator know if, or you give them a chance to know if they're overloading the rack. So the image on the top right is a load capacity plaque, right? And this one is rather straightforward. It's saying, don't alter the structure without asking for an engineer or the supplier. Don't climb on the racks ever. Report all damage, conduct regular inspections, and so on. And on the right, you've got, what's the maximum load that you can put in there? These are 2,500 pound pallet, very typical. And there's a picking level at the bottom where you could put a total of 2,500 pounds, right? So that's interesting. There's another way to put it, because sometimes you've got, these historical, a rack system that's got 20 years has gone through plenty of changes through time. And at one point, you've got all these differences. So when we come in and we measure everything, sometimes it's not super uniform. And one good way to operate these is to give you these load capacity labels. So that's the picture on the bottom. We can see this max capacity per pair of beam is 5,000 pounds. And at the very bottom right, we're saying what are the beam gaps. So this is really interesting because you look at the label and you can check if it matches the beam gaps that you see out there, right? And so there's no engineer stamp on this, but of course it should match the LARCs. Overloading risk. Of course, if you don't follow what you had in your LARCs, there's always a chance that you could overload a system. The image on the right, this is an output from our software and the report, the engineering report that we do. So we provide you with this view in our web app. And so you can know, okay, well, oh, I see. So B1 is 2,500 pounds, B2 and 3 is 2,000 pounds per pallet. And then in B4 and B5, I've got these variations, right? And sometimes when we see that it's non-uniform, we can help you and say, well, it's non-uniform because the first beam elevation on bay 4 is smaller than the other ones. And it's the same for bay 5. So if you change your beams back to what it should be, then you will have that 2,000 pound uniform for these bays. All right, so the point we wanted to make about moving beam elevation is this here. So changing beam elevation greatly affects load capacities and can put employees at risk. So usually if you move, you want to double stack at the floor level and you move your beam for that, you might have diminished considerably the capacity of the rack. And we'll show you this in a little video here. So this is the same as I've got on my right or left. depend in the back. So my colleagues are loading this with 3x3 1/4-inch thick steel plates. This is foam core, right? Your children could do this as a project. So you can see 4 levels, fully loaded, no problem. So we come back in, we just cut out the first beam elevation, making the first beam elevation twice what it used to be. And we're trying to reload it. So you see my colleague is holding it because as soon as we started trying to load it, we could feel it wobbling. So if he's not there, it would have probably fallen before that. And now look at that. It's not that he pulled it, you know, it was just super unstable. And so what happens with this is that we lower the capacity by a factor of 4, not 2. It's a factor of 4 because the length between the floor and the beam is squared in our equation, and it's a divider. So we can see that reality totally matches what we do in terms of calculations. So if you have to move a beam elevation and somebody had a calculation done and said, oh yeah, sure, you can move it 24 inches higher up, and then you can double stack at the bottom for some reason. So an engineer stamped it. Mind you, when you do the change, you cannot remove all the first beams throughout the system and then move them up. You know, it's one bay at a time so that you're still supporting the rack at that elevation while you're moving it up. On our website, you will find for free these documents here, which outline some of the things that I just spoke about. So we have a practical guide to rack damage assessment. And this one, you download it, you keep it on your phone. So it's perfect sized for an iPhone or Android, whatever. And so you can reference to it, you know, just swipe and you have all the inspection elements that you also have here on the right. This is our rack safety assessment guidelines poster. You can put that in the break room or lunch room, and people can refer to it and say, oh yeah, so I saw this twist, or just as a reminder of what they should be looking out when they walk the aisles for inspection. All right, so understanding damage severity, we're getting into one of the most difficult thing is to evaluate how bad a damage is. So we tend to divide this in 4 categories. Of course, the first one is unload, and we've seen some examples from Eric where it was so bad that, you know, of course, you unload pallets from there. Then there's high priority where we say, oh, this is pretty bad. Maybe we unload, you know, a couple of pallets at the very top, but, you know, it was still holding the load. We just don't want to take any chances, but, you know, it's not a full unload. And then maybe you have something in that gray zone where, you know, you enter that gray zone, you're in the moderate zone, and there's low priority issues. Sometimes we could say, you know, oh, you're missing a nut. It's a low priority, but you have to take an action. You know, you have to do something about it. Other than that, it could be, it's a little dent on the beam, you know, just watch it so it doesn't get worse. A safe unloading method, you know, the center column here, the middle column is badly damaged. When you saw it, everything was loaded and you're saying, oh, I don't trust this, we should unload. Well, sometimes we recommend, okay, well, you know, you saw it, it was fully loaded, just unload the pallets nearby. So you remove these 6 pallets, you don't have to remove 12. All right, so that's one way of addressing the situation while you wait for a repair kit to come in or a replacement upright. Of course, if you have plenty of space to spare in a warehouse, which is rarely the case, well, then you can remove everything because anyway, you're going to have to intervene on this upright. So examples of unload situation right here on the left, we can see badly damaged horizontal brace. Even the diagonal is sort of twisted and bent, but the column, look at that. It's like 1.5 inches or even 2 inches off. That's an unload situation. This one, I don't have to say. This one as well, a drive-in system. You can see the top pallet almost about to fall, and that badly damaged column right there in the middle. Other unload situations, right? This is a structural steel column. Oftentimes people tell me, oh, structural steel is much stronger than cold form steel. It is for local dents. That, you know, a little punch, little local dent. it is stronger. But a rack structure versus any forklift, the forklift will always win no matter what, right? So you got to be careful. This is an example of a structural steel column. Look at that. Look at that. And it's holding ice cream. So this was a fully loaded system. This is a typical unload immediately, because if it goes, it really goes. This is an example of repeated damages, right? At one point, and it's still holding the load, and it might be 10 years. At one point, the engineer that was inspecting said, yeah, but I understand, but we got to stop this at one point, perhaps fix it, and then put a protector, and you'll never hear about it again. Some more examples. Yeah, double stacking at the very top there. And we have a very badly damaged beam. So this is a full unload of the beam that should be done. Yeah, nothing to say about this. And a badly damaged beam, but with repeated impacts. You can see this has got to be, I think it's a reach forklift. And you can see the bottom tooth that's been torn and the top one about to go, and there's still pallets there. So therefore unload. High priority issues look like something like this. This is a structural steel brace and column that we see, a double column, by the way, and the weld is broken. Now, badly squished column calls for a high priority issue, and this is a particular case. The column is rather heavily loaded, and if you ask me, well, yeah, of course, I lost some capacity, but come on, it's got to be still okay. Yeah, it still has some capacity, but in order to stamp and to say, yeah, you're good to operate, you're safe, and put my name on it, I'd have to take it out of there, put it under a press, probably destroy it, and then tell you, yeah, you were right, for your 2,000-pound pallet, it was okay. But this was originally designed for 2,500 pounds or 3,000-pound pallet. Badly damaged beam, you can see the broken weld. So this became a high priority because when we inspected, it already had yellow tape. So it used to be an unload, and now it was a high priority. So by the way, I always say this, different inspectors will disagree on the priority of issues. It's a given. We have to understand that it's impossible for every one of you to see things exactly the way I see them, or that the inspector, when he was on site, saw them. Sometimes you look at the height of the system and you're saying, wow, this is 7 beam levels. It's more than 30 feet tall, a huge amount of load on the column. I'm not going to mess with I'm not even going to tolerate much because it's really impressive. Another high priority here, a damaged beam. It's rippled. It perhaps, because it's damaged from the bottom mostly, it probably has enough capacity. But again, it goes back to, yeah, but do I really know? No, I don't really know. And this one, by the way, was doing like a vertical arch. So you reload it. The worst that can happen is to have it come down. What we don't see in that picture, and part of the reason why it was high, is that it's been deformed by raising it, probably impacting it. And you got to go and see the connectors at both extremities, because at one point they are affected. And it's hard to see, but sometimes the column on which they're attached has been affected. The holes on the side has been strained laterally because of these stresses. It's a great example here. Looks great, no damage. Actually, we don't see any damage, but the fact is there's a missing diagonal brace in here. It's not even there. So it calls for a high priority. If we were in a seismic zone, I would say unload, because the diagonal brace is the one that's holding the upright from collapsing, in the cross aisle. In the event of a seismic event, we need those diagonal braces. They're essential. The horizontal braces as well, all of them, even the bottom one. Now, missing anchors here, the inspector saw this and said, yeah, this is operated by forklift. It's a high priority, just fix it. And it's an easy fix, to add an anchor. Moderate priority issues look like this. You enter that gray zone, in the 1, 2, 3 rule. a frontal impact is 1/8, a side impact is 2/8, and brace is 3/8. So this would apply. It's a side impact. It would be 2/8 of an inch. You're entering that gray zone. Therefore, we put it in a moderate. When you're looking at something and saying, is this low or moderate? You know, just take the higher one, moderate, and you'll be fine. And this feels like this case, you know. This one, the angle is not really great, but repeated impacts on that little column there at the bottom, you can see that it's been deformed inward. It's not a high priority, that's for sure. Is it a low or a moderate? As soon as I ask myself, is this low or moderate? You know, well, it kind of hints that, oh, just put it moderate. And we will see how many, when you're done with your inspection, you look at how many high priorities and unloads you have, and it gives you a sense of the importance of your moderate issues, because you got to fix the high priorities first, right? Other examples here, we have a slightly deformed back lip of a column, and we have here slightly deformed diagonal brace that just entered that gray zone. So what low priority issues may look like, this is a safety bar that we're pointing to, and it has moved all the way to the column. That's a low priority issue. It should be fixed at just about 1/4 inch of the pallet position, right? But it's not affecting load, it's not going to fall. And this one is not at the very top. So if it falls, I'm not gonna kill anyone with this, right? So, you know, low priority. Missing nut here, that's an easy fix. If it's in a non-seismic zone, which I assume it is, you know, there's no real uplift for that upright. So just come in, put the nut. On the right, we have deformed lip of a brace, you know, also a low priority issue. If I'm not in a seismic zone, it's not gonna be solicited much. This is an issue because the code says you have to leave 3 inches off the column, right? So pallets must not be really close to the columns like this. You got to leave at least 3 inches. There's 2 main reasons. For inspection, if they're glued like that to the column, I don't see anything. I can't see really the bracing. I don't know if it's damaged, so you're not protected. And the second reason is for water trickling from the sprinklers. So if everything is blocked like this, it will trickle on one side, you know, between the 2 pallets perhaps, but nothing will come down around the upright. Sorry, I skipped the last one. It was a slightly twisted shim at the base. And honestly, I think you can come back with a hammer and just hammer it back in place. And this one should do, because it's not super heavily loaded. In terms of priorities, you have to understand that accumulation of 3 low priority issue on one upright might lead to something that is more important. And we mentioned this at the onset, you know, all these little things, they sort of add up at one point, and we don't know where we stand anymore. So you got to watch for those as well. We have a little priority issue priority quiz to help you try and focus. So how would you guys rate this when you see how badly deformed the beam is over here, right? And again, you might think something and we will disagree. It's very possible. This one looks like an unload to me. It's deformed from top to bottom of the front face of the beam. It's out. Yeah, no one has a question on this. It's unload. This one, yeah, somebody could get hurt, you know, because the wire mesh is going banana. Yeah, it's a low priority to me. Squished back column over here. Okay, well, depending on how much load there is in there, you know, the inspector at that time said, yeah, to me, that looks like a moderate one. A beam that is slightly disconnected, what do you think, right? So this is unload. Right now it looks unload, so it might have been rated high priority, but there's no yellow tape. So if you want to rate something high, which should be an unload, you know, you have to have that yellow tape. This one here is, I don't know, just above the right pallet, there's a little side dent on the column. And the inspector thought that this looked like a moderate priority. So again, it goes back to, okay, how much load is there on this thing? How bad is it really? A badly twisted horizontal brace would be a high priority. If you're in a very high seismic zone, it might be an unload or a partial unload. So you could leave it at high, but say, I want to remove the top 2 pallets just to be safe. This is like a very high priority. And I'm not sure about this one. I'm not sure where it was taken. I can see there's 4 anchors in the front column. I'm not sure about the back one. So maybe this one could have gone a little bit higher. So it might be high priority with a side note to remove some of the top pallets, but not the whole thing. This beam looks deformed, but actually it's a very minor deformation, and I would leave it as is. So I took a note saying, yeah, I can see it's like slightly warped, but I'll leave it as a low priority. Just watch it.
Perfect. Thank you very much, Charles. Much appreciated. I'm going to turn back my video. And yeah, we wanted to wrap things up. I know we're a little bit over our time, but we did want to wrap things up just to share you a couple of tips and tricks on how to implement an inspection process. So, what are the components that you want to look at when creating your own protocol? We have a few recommendations, or, what are things that you should be looking at? Number one is the frequency, right? So how often should we be conducting that inspection or that self-inspection? Important question, who should be doing it? What should be reported, and how do I record the information? So again, we're going to give you a couple of those tips on what to do. And again, these are truly strictly some recommendations. So let's talk first about frequency. We strongly recommend that an inspection should be done annually by a third party. The reason why we say that is that sometimes having just a different set of eyes on your entire warehouse is an important thing. It can be refreshing. Sometimes, employers are going to see basically their warehouse the same way for such a long time. They don't necessarily see components that could be risks. So having that third party engineering company being out there to do the inspections is a very common and a very recommended practice for companies. That being said, you don't need to get necessarily an engineer come down on a monthly basis. That can get pretty expensive. And we strongly advise that, different warehouses or warehouse owners or companies should have their own inspection protocol. This can be done by, training a warehouse employee. It could be a dedicated person, and it doesn't take that much training, as you guys can see from these components, to be able to identify, issues and determining that severity. Beyond the monthly inspection, it's good to have this ongoing program. We're talking about the posters, the little pamphlet, being able to educate, all workers, frontline workers, and being able to them report when they see damage is a good thing. Versus if you wait till a monthly for a monthly inspection and something happens or a damage is serious that causes a potential collapse in between, that's a problem. So being able to have the right reporting process, but most importantly, a good maintenance program in place is a healthy thing for the organization. Whatever you do, make sure you document everything. If you have audits, if you do modifications to the rack, if you've done repairs, keep that documentation. It can get requested when you have an inspector, an OSHA agent, so on and so forth, to come in and ask for that documentation. So keep that information handy. In terms of protocol, inspection protocol, what should you have on record? So Charles talked about it. Make sure that you have your up-to-date LARCs drawings. Make sure you understand what is the racking, what it's the design, what can it hold, and is it the most recent configuration it has. Have your documentation of regular inspections. It's good to maintain all of your training records. If you've done repairs and modifications, as I said, keep that information and any other types of reports that you might find valuable for anything that touches your racking. A lot of people get nervous when they think about, a self-inspection. I have to go out there. I have to figure it out, but it's really not that bad. For those of you who are interested, we have a sample checklist that you can download off our website, and it's very simple. Simply identify the location of that rack. Most racks are each column are identified with a position. Create your nomenclature to determine what is the position of that, the upright, the brace, the beams, etc. identify the priority. Again, there's going to be different opinions sometimes on a priority, but try to get an understanding of how quickly action is required. And again, just a couple of observations or action, a call to action required on those issues that are identified. So on that really kind of recaps our webinar. If I was to summarize a couple things, we've gone through a lot of material, but remember these key points. Number one, don't forget, damages, issues on racking, especially when compiled, will reduce your load capacity. And again, when we look at these rack collapse, a lot of times load capacities can be the source of the issue. Second point is, make sure that within your warehouse or your organization that there is a safety culture, and a simply way to go about it is just make sure that there is a comfort zone where people can report issues, and they can not only just report the issues, but there's a call to action in order to address damages. And most important, those damages cannot be ignored. Those issues cannot be ignored. Make sure that there's action that is taken ASAP. We didn't talk too much about that, but in the event that you see that there's just a high risk of potential damage, and even though there hasn't been a damage yet, if you see an opportunity to better protect your racking, for example, a high traffic area, be proactive, and you can take those measures in place. And the most important point to remember on today's discussion is, if you see something and you have doubt and you're not sure or it's unclear, don't take any chances, unload the rack, and everyone stays safe that way. We talked about it. Please do not hesitate to visit our website. We have our damage assessment guide and poster. We have the sample checklist. We have other great information on rack safety guides that you'll find useful. Again, all available free of charge on our website, damotech.com /resources. And of course, if you have any questions whatsoever regarding your racking and you're looking for that extra support, please do not hesitate to reach out to us. Damotech, we are a rack safety partner. We offer a variety of different services. So on that note, thank you very much for your time. Really appreciate the engagement with everyone. And I know we've gone a little bit over time, but we are going to take a few questions. So let me get started. So Charles, I'm going to ask you this first question. So we are talking about the differences between a high priority and unloading, but is there a determining factor that that says it's that there's a trigger where you have to go from a high priority to an unload? What's that determining factor?
That is a good one. Our own engineers, they are trained to understand how loads carry from top to bottom, and they also have that sense of knowing, okay, I'm in a rather high seismic zone, therefore I will act accordingly. And so, of course, they all have that engineering background to take that decision. And whenever you're standing in front of something and you're looking at it and you're wondering, is this a high or a unload? The answer is unload. If you're wondering, you see that take that road, there's no problem there. If you think, like I said, I'm not sure, I'm really honestly not sure I want to unload the whole thing, you could put it as a high, but recommend to remove the top two beam levels, and just to be safe, because oftentimes you realize there's a damage and everything is fully loaded right now. So it's still capable of taking something. You just don't want to risk it if there's another impact somewhere else in the system, vibrations, whatnot. So yes, you can remove some of the load.
Perfect. Here's another a good question, and I'm going to let you answer it, Charles. Do you offer training for employees to become certified inspectors? So what's the training we offer?
So there is yes, we do offer training to help you out become better inspectors, but there's no certification in North America to become an inspector. And like I mentioned, an engineer will have a totally different point of view, knowing how forces travel through these systems. And so usually what we recommend is having a third-party engineering firm like Damotech. That's what we do. And we come in once a year, we assess the whole thing, looking at if you're respecting code at all these different places. We also offer that load capacity calculation, which brings you back to correct LARCs, up-to-date LARCs on everything. So you're really in control of the situation. And then on a weekly or monthly or every 3 months, you have people inspecting your warehouse. Sometimes we say, you could walk every day depending on the size, but you just focus on this aisle. I'll do anchors and the bottom portion. The first 48 inches is where most of the damage arises, because you back into racks and so on. So you might just focus on that, but there's no certification as such.
Another question here is regarding wire mesh. Does it have to be secured on racking, yes or no?
Very interesting. Very interesting. I don't recall seeing anything on the design code about this. I would have to go back just to make sure. But the basic principle is a bit like the safety bars. You don't expect the wire mesh to move left and right, because usually you have two of them. They bump into each other, so they're not going to really fall. But I've seen situations where they would raise their pallets, and they would do it rather close to the beams, and that sometimes they would just raise the wire mesh with it, and it would just fall behind the rack or in the flue space between them. And so what they did, they tied them up with tie wraps. And I couldn't say it was a bad solution, actually. It was an interesting solution, very easy fix. They didn't have to drill it in the beams. They didn't have to fix them like that, and it seemed to work. Now for safety bars, usually they have holes either horizontally or vertically, and we don't have a problem with creating a hole, screwing something in the top of a beam, because in terms of compression, it's sort of connecting with those holes, as long as you don't leave them empty, basically.
Perfect. Wonderful. Here's a question here from Brad. Does the code apply to Canada? So yeah, so we did talk about that at the beginning. So the Canadian codes through CSA is S16-19, correct, Charles?
Correct. So since 2019, we have the Appendix M in M or N? N in our steel structure design code. So this is the same code to design buildings in steel. And there's an appendix that pertains only to rack systems. So it's a slightly different code, especially for seismic analysis. But it's a very reliable approach as well.
Perfect. A question here from Fernanda. Yeah, is Damotech online training on rack inspection available only in English? And Fernanda, happy to say that we offer multiple languages. We also offer French, and Spanish is also available. We do have a few experts who are trilingual on our team.
More than a few.
Yeah, exactly. A lot of questions here. I'm sure we're going to use, probably going to go through a couple more. Do the LARCs need to be posted for everyone to see? We did cover that off, and the answer is yes. Do they have to be communicated some way, somehow?
So just a quick exception. So we're talking LARCs. So no, the engineering drawings, no, usually you keep that in a vault somewhere. The load capacity plaques or load capacity labels have to be visible. And the spirit of this thing, give a chance to the operators to understand if they're overloading a rack or not. That's about it. Perfect.
This one actually a bit of a continuation. You were talking about, someone was asking about certification to do inspections. So here's another different question. So what kind of training makes a worker trained to do these monthly inspections?
Monthly inspection, yeah. So knowing what to look for, and I think what we covered today is pretty good. We can delve. Some people will. It may take a full day of training. We never do that. We try to keep it in a 2-hour class, right? We take 2 hours with you and we look at these details, then we walk some portion of your facility with you to try and pinpoint some issues, because all these systems, they're so different. It's really, really hard to cover everything. Some people have drive-ins, some people have cantilever systems, you know, with these arms sticking out. And you'd have different situations, different slab slopes and whatnot. So sometimes we see out-of-plumb systems. So yeah, a 2-hour training to us is enough for an employee that knows the place and that knows the types of racks to be able to do their own inspections. Now, it will never be the same as an engineer walking the facility, I'm sorry, because of the training that they have, knowing how these forces go about, and especially for those in seismic zones.
Yeah, that's good. We'll take that. Unfortunately, there's a lot of questions. We'll do our best to answer them afterwards or offline. But here's the last question from Jeremy Graham. What are your thoughts on low capacity labels placed on every beam as opposed to the capacity plaques at row ends?
Yes, so we do both. Oftentimes it depends on the needs of the client and also the variety of capacity that we have throughout the systems. Oftentimes when we go in these places which are rather old, they will have a portion of the rack that has 2,500 pound capacity, then 1,800 for some portion, and then back to 2,000 pounds. So there's a lot of variety, and we're thinking of the operators, you know, trying to figure out, you know, what to do. And we would just say, well, if you want a low capacity plaque, it's going to be the common denominator at 1,800 everywhere. And then you lose quite a lot of capacity for all these slots. And you have to sort of maintain this, right? So oftentimes the low capacity label, which also states these beam elevations, you know, for these rack systems where in the same system, in the same row, you have beams at 5 beam levels here, then I've got a tunnel with 3 beam levels at the top, and then I go back to 4, and then it's something else at the end. There's a lot of variety, and you might not have that uniform capacity. So in these cases, low capacity labels are really interesting. We don't put them on each beam level. So it did happen that within the same bay, you had different low capacity because of the beam sizes. So usually we try to make this uniform because, again, you don't want to have 2 labels, one saying, you know, first and second beam is 2,500 pounds, and then it's 2,000 above. So the nice thing about the beam labels is that you can change them rather easily, and they also indicate the beam elevations. So, and there's a date, you know, everything is. So if everything is uniform in your warehouse, we've said that to people, they were handling, you know, boxes of paper, just storing boxes, and they're all uniform, same capacity all over. They just had one big plaque saying the capacity per pair of beams, and that's it. There was no end of aisle plaque everywhere. It was just known to everyone operating this thing. This is what it can take.
Wonderful. Perfect. So that's pretty much all the time we have. Thank you for those who stuck around for the Q&A session. Thank you very much. I know a couple of questions. People were asking for a copy of this presentation. We have a lot of information on our website. We have a lot of blogs that you'll find lots of great information. For some of the content seen today, we offer this through our training programs or training sessions. And again, please do not hesitate to visit our website to get more information. Anything that you may need, or if you want to talk to someone directly, again, go to the website. You can call us directly and we are there for you. With that being said, thank you very much. Thank you for your participation. Hopefully inspiring and insightful for some of you. Until then, please stay safe, and we will talk to you soon. Bye for now.